Welcome everyone to Tainted Love. This is a custom rule writing workshop. Yeah, so I guess I'll just go ahead and get started. My name is Jason Kinsfather. I'm a solutions engineer here at Semgrep. I'm joined by my beautiful assistant, Claudio Merloni, who'll be helping me today. He's a security research manager. This is going to be recorded. Today we'll be focusing on just, I guess, how do we write custom rules with Semgrep? How do we write custom rules with Semgrep's Taint Mode? There is an assumption with this course that you have some familiarity with Semgrep and how to write Semgrep rules. So I won't be doing a full rule writing 101. However, we will touch on some of the basics here in just a second. If you want to get started, we will be doing some rule writing exercises. If you want to save the progress that you make with these rules that you're writing, the best way to do that is to log in to the Semgrep Cloud Platform at semgrep.dev/login. From there, you can open the rules editor and you'll be able to basically fork the rules that get pasted into the chat. So we'll post the exercises in the chat. You can open them, kind of work on your solutions. I'll be asking for crowd input, so I'll be monitoring the chat throughout here, and so will Claudio. I also have a link here to the rule writing docs for Taint Mode, if that could get posted into the chat. And we also, in addition to the chat here, good morning, we'll also have a Slack channel set aside in the Semgrep community Slack so that even after we've completed the workshop here today, you can still ask questions and receive some feedback and so on and so forth. All right, and so with that, we'll go ahead and get started. Now, why are we here today? Why do we care about custom rules for static analysis tools of any kind, not necessarily just for Semgrep? Well, I'll tell you why. Because as professionals who use application security testing tools in our day-to-day work, we don't care just about finding things. We care about fixing things. And the research has shown in our own customer base that people who write custom rules, who tailor them to the applications and code bases at their own organizations, have up to a 50% higher fix rate for those rules than just the ones out of the box. Indeed, even at Tide, which is probably the exemplar, they see a 100% fix rate on every custom rule that they write. And the great thing about custom rules with Semgrep is that they're pretty easy to write. If you can write code, you can write a rule. And we see this get scaled not just to the security team writing rules, but also to developers as well. And this is borne out in independent research in academia as well, where we see industry-leading tools like CodeQL having only about a 60% fix rate out of the box, whereas ones with customization having 98, 95%. These are pretty eye-popping numbers. And this is kind of what we see in terms of our customer involvement as they adopt Semgrep as a scanning tool for either first-party code, third-party code, or secrets. They get it in their system, they crawl, they walk, it becomes part of their everyday methodology. They kind of work through their backlog through run, and then they start to fly when they really make the tool their own and customize it. And that's how we see the most value and kind of success, is when people really start to make it their own. Now, if we're going to write custom rules with Semgrep, we need to understand how the engine works. And Semgrep's engine works in two different modes of analysis. The first mode, if we could welcome her to the stage, is Semgrep search mode. This is your run-of-the-mill, everyday Semgrep. If you've written a Semgrep rule, this is probably what you've used. Search mode takes a pattern and searches your code for that pattern, typically by taking the source code, for example, this app.py, transforming it into some kind of abstract representation, takes a rule, also transforms it into an abstract representation, and then tries to match the two of them and returns the response. Now that's kind of abstract, so let's continue to just kind of see what that looks like in a rule. So this will be our first exercise for the day, just to get you warmed up and started. Just some basics of Semgrep rule writing in general. how Semgrep rules work is we're going to write some patterns, and then we chain those patterns together with some logical operators and make them more complicated. And so I have a rule already started here, just to start off the bat. And if someone could post the link into the channel, thank you. So welcome to the Semgrep editor. This is going to be in your browser, so no need to test on the CLI. If you haven't used the editor before, the rule that we're writing is here in the middle. And off to the right here, this is the code that we're testing the rule against. I hear that it is blurry. Do I need to embiggen? Because I can. Is that helpful? Is that good? One more. Haha, how about that? All right, so perfect. So when we're looking at writing a rule, I just clicked run in the lower right-hand corner, and so Semgrep runs the rule that's written. Right now, it's just searching for, to do, which doesn't exist. You might notice that we have some tests that triggered. 2 of them failed, and then 1 of them passed. So the way that we can test our rules is using some special comments. These test assertions are like so. If you see a comment with a rule ID followed by the ID of the rule, this tells Semgrep, hey, Semgrep, you should match here. And if you are not matching here, that's a problem. If you are matching, great. If you see OK, that says, Semgrep, this code is safe and you should not be matching on it. If you are, it's a problem. And so as we kind of do our exercises today, we'll be writing rules so that we can, match the test case we want to and not match the ones that are safe. Now, to get into the particulars of this specific use case, in this case, we're looking at some Python code here where we're instantiating some kind of Elasticsearch object that connects to an Elasticsearch instance. And one of the potential parameters on this is a bearer auth parameter that takes in some kind of bearer token. And we want to make sure that whatever this token is, it's not a hard-coded string. And so with Semgrep, we can start to write a pattern to match this kind of thing. Now, since I assume that y'all have some familiarity with Semgrep, I'm going to kind of ask from the crowd and give you an option to take a second to see if you can write some pattern that will match these cases where Elasticsearch is being instantiated with some kind of hard-coded password. So if you could write those, drop them in the chat. We'll then check and kind of see what's effective. So I'll give you about 20 to 30 seconds, and then we'll move on from there. Alrighty. See one person typing, another person typing. So I see a bearer auth equals A through Z. Yeah, we could potentially do that. We're not going to be able to just put the regex in there, though. So in this case, I want to make it a little more specific so that we're not just grabbing any bearer auth. So I'm going to try to just search for the Elasticsearch instances that are instantiated with that parameter. Otherwise, it could be a parameter in any object. So one of the cool things about Semgrep is that it does have namespace like understanding. So we can say, hey, from this package Elasticsearch, let's grab the Elasticsearch object and an instantiation case. The first thing we'll do is use our Semgrep operator, the ellipses, and that tells Semgrep, hey, and yes, that's the perfect answer there. Semgrep, at some point, something could be here, nothing could be here. We don't care what it is. The ellipses just tells Semgrep, just kind of ignore whatever it is. We don't care. And since bearer auth is one of maybe, I think there's like 30 parameters that are possible for Elasticsearch, and we don't know where in the list it's going to be. And then we can, of course, write in our parameter and say it's going to be a string. And then I'm going to use my second operator, metavariables, to define the value of the string. So now if we run this, this is cool, this is great. And now we're going to match on every single bearer auth instantiation, which is fine. However, I think we want to make sure that this is not an empty string. So down here we see, we have not a password being set to an empty string and then passed to bearer auth. And we kind of want to eliminate that out. So I think we can use some of our more logical operators to kind of build that stuff up. So with Semgrep, we have things like patterns, pattern not, pattern either, which kind of act as a and, not, or clauses. So I can use patterns, that's my and clause, to say, hey, like, let's use this pattern, and let's also restrict it. So I'll say, and I can't spell, but let's see, let's do like a meta variable regex, and let's restrict the value of bearer auth. So let's say like, we want this meta variable, which in this case is, I don't know why I called it rec, but that's fine. And then let's grab any like not white space and see if that can kind of eliminate that. So with the kind of propagations here, so like for example, we're propagating the value of these variables and whatnot. They're going to be pretty standard across all the languages. Where you might get into some stuff is with Semgrep open source, it may not have as good of an understanding of like the standard API or the data structures of a language, but that is really on a language per language basis. If you're using Semgrep Pro Engine, that will have a better understanding of those standard APIs and data structures and be able to propagate things fully. But to get into the specifics of that would take us some time. So anyway, so this is Semgrep search mode. We wrote a pattern, we matched the pattern. That's fantastic. That's great. That's really cool. We love search mode. At least I do. However, I'm sorry, search mode, but you're not the only one. Someone else has been in my DMs, someone who has style, someone who has a little bit of banter and confidence, dare I say it, money. And I'm sorry, search mode, but we are kind of done. Taint mode is actually way cooler than you are. And let me tell you why. Why do I love taint mode? Well, let me count the ways. As we just saw, like search mode, it just finds a pattern and it just calls it a day. But taint mode is a juggernaut. It does more than just find a single pattern. It will keep moving. It will follow the flow of data through data flow analysis. It'll go across functions. It'll go across file barriers. And like a bloodhound, it will stalk and pursue undeterred until it finally finds its prey. And that's what makes taint mode great, is that we can actually track data through applications, follow that flow, and come up with something a little more advanced and interesting than just a single pattern. Now, if we want to get a little more intimate with taint mode and understand it, we need to understand where it's coming from. And to do that, we're just going to review a little bit of terminology here. So when we're talking about taint, taint has a particular set of terms. We're following data through the application, and the data has to come in somewhere. And that source is called a taint source. And that's usually some kind of user provided data, like URL parameters or cookies or some kind of third-party service, a place where an attacker could potentially inject malicious data. And that data is going to propagate and propagate through what we call propagators. Those could be functions, they could be methods, they could be objects, classes, etc. And it's going to go throughout here, propagate, and get to some kind of sink or endpoint that is vulnerable. So that could be like some kind of OS, call, or a SQL query that someone forgot to parameterize. A place that if that malicious data got in, it would be a problem. So let's talk a little bit about how to write taint mode rules. We looked at the match mode rules or the search mode rules, and those were pretty basic. With taint mode, the syntax is a little bit different. There's 3 things that are required to turn a rule into a taint mode rule. The first of those is a flag that says mode is taint. That tells Semgrep, hey, we're going to write a taint mode rule. Then we need a pattern sources block. And so the pattern sources, again, are where the data is coming in, and then the pattern sinks block, which is where the data is going out. That's the bare minimum that you need. Now, you might say to me, Jason, But wait a second. I see under pattern sources, I see a pattern. And under pattern sinks, I see another pattern that looks really similar to the pattern that we just saw in the search mode rule. I would say, well, you got me. I claim that I love taint mode way more than like search mode, but that's really not true. Because if we look at any taint mode rule, take off its hood, it is a collection of search mode rules in a really fancy designer YAML suit. And that's really important to acknowledge when we're looking at taint mode rules and writing them, is that we're really just kind of writing some search mode rules for the sources and the sinks, maybe some propagators, sanitizers, etc. Um, and just kind of Semgrep is then doing the wiring to look for those patterns and then connect them up together. And that's the beauty of taint mode. So with that, we can kind of begin and get into our exercises for the day. We're going to start out easy and then introduce concepts and features with each rule. So let's get going. Now we're getting into, just the most basic like taint mode rule, where we're going to be tracing some data originating from HTTP request. This is in Go, and we're going to find where is it being used in some OS calls that open files. And I'm going to illustrate some of the default behaviors of taint mode propagation here, just so you can kind of understand what those are and how things will behave. So let me go ahead and go to the rule here. So my taint mode rule here, I'm going to scroll down here to, because we don't really care about the imports as much. So what's happening here is we have some functions that take in some, HTTP requests that we're going to take some data off of the request, and then that data is going to be passed to, some kind of OS function. Now these, sinks could be in another, in a class's method. They could be in another file. For the sake of testing today, I'm just going to include them in the same function, but Semgrep would perform the full data flow if we were testing in like a real life environment with multiple files and everything. Now let me go ahead and run this rule so we can see how things perform with our empty rules. So we're trying to match 4 different things here. And so I guess the way that I like to start writing taint mode rules, I like to start from the end and work my way backwards. So I like to start with the pattern sinks and then my pattern sources. It's not really any hard rule. That's just my methodology. And so I'm going to kind of ask the crowd, what is a pattern? And remember, it's just a search mode pattern that would match our sink here. I'll give everyone like 20 to 30 seconds to contribute to the chat. Yeah. So the pattern matching will be case sensitive, yeah. If we're like trying to match like a specific method, for example. So I think, yeah, we've got OS to start. Someone said like OS, like meta variable here. That's fine. That would match any like method on OS, which is probably maybe appropriate. I think just for our purposes today, we'll just stick with os.open. And then the cool thing is we don't really need to specify like, hey, some kind of variable like argument is going to get passed here. Taint mode will actually take care of that for us. All we need to say is like, we just need data to reach this call. Since we don't really care like which argument, which parameter the argument's being passed to, we don't really need to specify further, which is kind of nice. And then for a pattern source, let's go ahead and try to write a pattern source there. And what's kind of cool too is when you're working on taint mode rules and testing them, let's see here, we've got 0 matches currently. Yeah, is you can kind of like, see your test cases and whatnot. Does anyone have a pattern source here that we can, use to identify? All right. Yeah. Yeah. So we could do like a whole like check where like a function is created that takes in like some kind of request that's of the right type and whatnot. But I think to make things a little more flexible, I'm actually just going to say like um, we're going to go for like we're going to make it super abstract and just say any kind of field on any uh, any like request. And the way that I'm going to restrict it is actually using something particular to Go and other strongly typed languages. Um, and I'm going to use a thing called metavariable type to restrict this further. So I can say like, I can use my patterns, my and statement. I can say, hey, let's do a pattern there. But let's also do a metavariable type where on the like metavariable request, I'm going to go ahead and give it that type, which is that like pointer to HTTP request. And so now should be able to save this. We've got some YAML nonsense. And let's make sure we run it. Cool, let me close this out. And so as we can see, we've now restricted it to that type. We could even restrict this further and make it a little more specific. So I could say like metavariable regex again, and we could put that on the field. And we could restrict that to like, I don't know, I guess. So we've got like basic auth, there we go, or like body or cookie, et cetera, et cetera, if we really wanted to make it like super explicit. Now, what's kind of cool is we can see, yeah, so metavariable type just takes a metavariable and it restricts the type to um, the actual like type of the metavariable so that it's not just matching anywhere. There is no list of metavariables. A metavariable is whatever you want to call it. So it's literally just a variable. So I could call this foo, I could call this, home, I could call it JSON. It doesn't matter. It's just a placeholder in the code. What can and cannot be on the type field. I'm not sure with Kotlin. I don't know, Claudio, if you've got an answer there. So when we're looking at the data flow, we can actually like look at the data flow diagram. And it's important to like kind of note this because when our rule matches in real world, like this is what a developer would receive is kind of like this data flow. So it's important that we kind of make that explicit and visible. We've got type and pattern. So with a metavariable pattern, I could actually like use a pattern instead of a regex. So if there was like some kind of if I wanted to like create like a, I don't know, if I had like an object with a parameter and a, sorry, yeah, an attribute, and that attribute has a value, like that value could be a regex, and then I could have like a pattern that makes that like pretty complicated as to what I'm trying to match. They're just ways to expand metavariables, basically, both pattern, regex, and type. So I think like this is definitely our like completed rule here, but I do want to illustrate what's happening in the code. So these are some like defaults that you should know about taint mode. The first is how string concatenation works. So if there's some kind of concatenation, Semgrep will taint the output of that concatenation. So since we have this tainted username being concatenated here, unsan path is now also tainted. The other thing that we should know is return values are tainted by default. So if we have some kind of function that returns a value, then it takes in that taint. By default, this would be tainted as well, this output. And so when that passes to OS, that's also going to be a thing. And then last of all, the way that we taint data structures by default is that if the data structure is past that unsanitary, data, then calls to methods on the data structure in the future will also be tainted just by default. If we don't have some kind of default representation of the data structure built into Semgrep. And so those three things are default settings. You can change them, and there's more detail in the Taint Mode docs, but I won't get too much into detail there. But yeah, it's just important to understand that functionality. So this is the basics of Taint Mode, our sources, our sinks, and kind of working across them. So I think next we'll go to another rule. This one is going to focus on some cross-site scripting and JavaScript. Again, we have data coming in from an HTTP request, but now we have two different sinks to consider for cross-site scripting. And now we're interested in a new kind of use case where, maybe we have some kind of sanitization or validation built into our, either as a standard library or that custom to us that we want to consider. And so when we're looking at this Express application, which it has like these HTTP like methods on these paths, and then it'll take in a callback function that has both a request and response object in them. We're going to try to track like where is that passed to this response.write, which will write back a response to the client and potentially put out some some code that would be bad. But we have these functions like clean xss. We have path.basename, which would sanitize like file paths or inputs. So we want to be able to consider those and include those and tell Semgrep, hey, we don't want a false positive here. So I think to start here, we're just going to start with our pattern sinks. In this case, we have two of them. And if I could just get some patterns for those sinks, then we'll kind of move on here. Yes, Christopher Powell. Yep, Semgrep can do data flow when the sources and sinks are in different files, different functions, different files. That is Semgrep Pro Engine. The Semgrep open source does not. It can only analyze single functions at a time. So in terms of our like pattern sinks here, I think we're going to make them like pretty generic in that we'll try to match our like response object, which these are kind of standardized. And then also response.write. So those are our two sinks that we definitely want to match, and we can run again, see how that does. Of course, it's not going to change anything. We also want some kind of pattern source. So can anyone provide a pattern source for me that's going to catch these request objects? We're thinking http.star. That's not going to be a valid pattern for JavaScript. .star is not going to be meaningful in the code. And we have request.x, which will work, at least for some of this. Unfortunately, it's not going to work for this use case, where request is actually being deconstructed, and then something from that is being passed along. And then we've got something a little more complicated here. We've got app.func and so on and so forth. Yeah, I think, Express has some pretty standard things here, at least within our application. So I could do, app, and we'll say like some HTTP method and a path that takes in, a rec and a response. And then, yeah, goes like that. We can definitely do that. Let me make sure that my YAML is all happy. Oops. And so let's go ahead and run this rule and see where that takes us. So that actually works for us. However, I think that it's going to be a little not great from a user experience, end user experience, someone who's actually has to read the output from us. And I'll show you why. If we look at the data flow diagram for this, we get this huge taint comes from this source app.get blah, 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 blah. And the reason for that is because our pattern source is now matching that entire function. So it's matching the function body, the app.get body. And so it's not very legible, and it's not clear where data is coming in. So we actually have a handy dandy little feature that we could use here. Again, I'm going to use patterns to kind of spruce this up. So one of the things that we can do is zoom in on that pattern that we created. And so I'm going to use a special operator called focus meta variable. And what this does is it tells Semgrep, hey, take that big chunk and focus in just on this meta variable. So in this case, what we care about is that request object, right? We don't care about the response. We don't care about the path or anything else. And so now if I run this again, we're still getting, matches as are appropriate. But now if we look at the data flow, the data is actually coming from the request object and not just anywhere on this app.get. And so now we can see that full data flow, and it's very clear and obvious. And we're going to lower the false positives that we get by really zooming in there. So the data flow will still show in Semgrep OSS. It's not unique to Pro. However, it won't do cross-function and cross-file analysis. It'll just be within, just like this example here, it will just be within a single function body. It won't travel outside of that. And so now we have one last thing to do, which is deal with our little our test cases that we don't want to match on, because they have some kind of sanitizers. So, the cool thing about Semgrep is adding a sanitizer really is as easy as just saying, here's what my sanitizer function is. And I could still use that same package kind of namespace fields if I had, if we had a package called mysani and it had a .clean, a clean XSS function. And so I have that. I also have path.basename. And so I can just provide those, and now Semgrep knows whenever taint flows through that function, it is clear, it is golden, and we are good to go. All right. And so that's, we've kind of made some progress here. We've been able to talk about the basics of taint mode, talk about sanitizers. Now we want to talk about propagators, which we haven't really touched on yet. Now, most of the default propagators for for the language API are built in, but let's say we have some kind of custom class that we need to account for. Um, we want to be able to also consider that within our rule as well. And so we're going to look at a Java rule. So of course, because it's Java, it's a little more verbose here. Um, Now, looking at pattern propagators, this is the syntax for pattern propagators. Pattern propagators are going to take some kind of pattern. So, for example, like if I had a function called string copy and it took in some kind of source string and then copied it to another variable called destination, Semgrep by default, may not know how this works. As we talked about, the defaults with functions is that the return value is what gets tainted, but we don't know that like destination is going to get tainted. So we need to tell Semgrep it'll propagate that way. And so with pattern propagators, we need two meta variables in the pattern so that we can tell Semgrep, hey, if there is taint on source, that taint then travels to our destination. And that's the way that custom propagators work. Now let's try to solve this rule as normal and then kind of proceed from there. So right now I have, this SQL service class that takes in some HTTP servlet requests and then, gets some data off of them. I mean, these are going to be true for pretty much all these exercises. We're going to get a parameter off of it or whatever. And then we have some unparameterized SQL queries that we're going to throw it in. So I think let's first of all, again, maybe focus on, let's change it up this time. Let's go for a pattern sources. Can anyone give me a pattern source that will work here? And remember, this is in Java, so we have strongly typed features here, so we can actually type our meta variables. I'll give people like 20 more seconds to kind of come up with a pattern source. All right. Um, what's kind of cool about Java in particular is that with other strongly typed languages, we had to do that whole like meta variable type and it kind of made it a little more complicated. With Java, we actually have like a easier syntax. So I can actually just say like, hey, let's type this meta variable as HTTP servlet request, and then here's the meta variable. So accomplishes the exact same thing, but just a little more clean. And so now any data that's coming off of that, HTTP servlet request is now going to be a thing for us. So Claudia, I don't know, is this syntax also available for Kotlin? Or is it just Java specific? So what's kind of cool here is now let's consider our pattern syncs. So these SQL executions here. Does anyone have a pattern for that? Well, I can go ahead and put what I would put down. Again, if we have some kind of like typing, if we know the types, then we can use them. Since I don't have domain knowledge, and this is kind of where it helps to have domain knowledge about the code that you're trying to match, I'm just going to use a generic meta variable. So I don't know, I'll call it Q. But I would type that if I knew what like create statement returned here, the type of that. And I'll call it like SQL query, the method on it. And then, I don't know, let's try to like constrain it a little so that let's use our meta variable like regex again. Oops, and now I'm carrying the pattern away. And let's give it like let's try to restrict the SQL query method to, let's see here. I guess we have execute or execute query, etc. And then YAML. There we go. And more YAML. Oh, I need to group these together with patterns. So I started my patterns block, but I didn't actually add a pattern for the pattern. So let's do that. And after our coercing of YAML has come to an end here, now we can run our scan. And we see, perfect. So we are now matching where we want to match, where data is coming into that HTTP servlet request. It's hitting some kind of execute query or execute. The problem is that we're now unable to account for this special case where we have this custom data structure called myStringList. And that myStringList is the method append is being called on some, tainted data called table name. And then list.getResult is being called. Semgrep doesn't know how myStringList works. And since we're not like we don't have myStringList defined in another file and bringing that into the picture, it has to guess. And its guess out of the box is, I don't know. So we're going to have to use our pattern propagators to tell Semgrep what to do. So in this case, we can write a special propagator for myStringList. So I'll call it myStringList. So we'll type a meta variable because again, we can do that here, at least with that nice clean syntax. And so I'm going to say, hey, whenever there's a myStringList that appends some kind of sensitive data, so if X is tainted, then I want the taint to go to myStringList, like so. And so now future calls to methods on myStringList will get tainted as well, the results of those. And so that's a way to add some customization, make this a little more unique. So we've covered pattern sources, pattern sinks, pattern propagators, as well as pattern sanitizers. Those are kind of our basic constructs. And so we're going to move on to something a little more complicated and what I think is really cool, which are called taint labels. So far we've been just handling very simple sinks, very simple sources, but there are cases where you might have a sink that is only vulnerable due to certain conditions about the code. So for example, we're going to be looking at a YAML parser that is only, the parser's like load method is only insecure when the parser has been constructed with unsafe as an argument sent to a parameter. And so we want to make sure that we are not matching when that hasn't been set. And so if we take a look at the data here, and I'll kind of do this one real quick just to show you how taint labels work. So we have like instantiation of the parser. It's explicitly passed unsafe to this type, and then we're passing it tainted data here. Now, if it's instantiated with safe or just no argument or any other argument, then it actually is safe, and we don't want to match that. So the question is, how do we do that? Well, I think we need to start just with our normal like sources and sinks. So I would say like let's start with a source that is from So in this case, this is like a handler method for an HTTP request. So I'm going to say self.path to make things easy for us. So way that taint labels work is that we can label our sources and then use those sources to do some logic of this source and maybe not this source need to be true in order for this sync to matter. So in this case, I need to label my stuff. So I'm going to call this user input because that's what it is. Now, I also want to grab the YAML parser when it's instantiated. So I'm going to write a pattern that is, let's grab YAML.YAML.YAML, and let's grab it when type is set to unsafe. Now, this is the reason why we're doing this is we can now declare this as a label. So we can label this like, let's label it type unsafe. And so now we have two different conditions. We have this this taint coming off of self.path, but we also have this tainted YAML parser. And so we want those two things to reach our sync to make it vulnerable. And so the way that we do that is first we just need to put our sync, which in this case is, sorry, I don't care what the name of it is, YAML.load, and then we'll require those labels. So we'll say, hey, when you have user input and this is like Python Boolean logic syntax to put these labels together, and that type is unsafe, then if data reaches YAML.load, it's a problem. And so now we can see we have restricted this. If I just had user input here, we would catch everything, which is not okay. We would catch even these safe instances. But with the power of taint labels, we can now make this a lot cleaner and a lot less noisier. Now, there is another thing here, and this test assertion is actually on the wrong line, of what if there was like another setting that actually overrid the first one, but really it's safe. Well, we could also add that as well. So I could, add this and then say, let's say, in the case that but really was set to safe, and let's call that really safe. We can now say, but let's not match when it's the case that it's really safe. And so we can continue to use our Boolean operators to, build up kind of the complexity of these taint labels. And so now you can see it's no longer matching because that also is true. So this is a really cool, just kind of basics of taint labels and kind of the power there. So we can really start to connect these different pattern sources and make them more conditional. I have one last problem here. We're going to get a little even more complicated, this time using something called by side effect. And so we, again, just like the last problem, want to consider conditions that'll make a sync either vulnerable or not vulnerable. But however, we were able to kind of say, hey, when this has been instantiated this way, that's a problem. But we need to consider what happens if, something is instantiated, but then it has settings set on it after the case. How do we then deal with that kind of that kind of workflow? And so the way we're going to do that is by using our by side effect, which is a pretty powerful tool in our toolbox. And so by side effect will take a pattern source and it will say, hey, if tainted data comes in this way, like what gets tainted by side effect? So if like a function takes in, as we talked about, like the default is that like the return value of the function gets tainted. But how are we going to taint things by side effect of them entering the function as an argument? Um, and this is useful because then we can put a taint label on this. Um, so for example, if we have some kind of function that takes in x, we're going to focus in on the function. And if tainted data enters the function, then by side effect, func becomes the source of our taint. And the same thing for like some kind of function that would make data tainted. So the safe data comes in, we focus on that, and by side effect, that is now tainted. So it gets a little more complicated here. Um, let's take a look at that in action. So we are back to Java in all of its verbosity. Uh, Now, what makes things a little bit different here is what we're going to do is take in some data from an HTTP servlet request with some kind of document builder factory. And the document builder factory is going to, of course, create a document builder. So we'll call new instance to create a document builder. And then that document builder is going to be used to parse taking in that request data, which could be a problem. Now, there's some difficulty here though, because we could actually put some settings on that builder factory that make the parse method of the document builder like safe and good to use. And so we have two different things that would need to be set. This external parameter entities setting, as well as this external general entities setting. Both of them are put to false, then our parser is safe. And so we need to be able to consider these factors when we're writing our rule. And we're running out of time here, so I'll kind of go through this pretty quick. When we look at our pattern sources, very similar to our previous rules, let's make sure that we have a label on them, though. So hey, this is user input, and the pattern is going to be, again, our HTTP servlet request. Okay, and let's create another label. And this time, this label is going to be related to a pattern where what we want entering our pattern syncs, and let's actually just write that right now so we can keep it in mind. Our pattern sync is going to be one where we have a document builder that comes from, so a document builder that the parse method is called on, right? Now, what's important to keep in mind is we don't want any document builder, right? We could instantiate a document builder separately, but we don't care about those. We care about the ones that have been generated by a document builder factory. And so we're going to use taint labels to require this to have come from a factory. And so I'll call this from factory. And then put a pattern in place for that instantiation. So let's call it document builder factory dot new instance. And so now we can make sure that that's the case. And so let's actually just like try our requires out here. We'll saw user input and from factory. Ooh, pattern is a required property. There we go. And so that didn't quite do the trick for us. Let me see here. Did I misspell servlet or something? If we look at our taint here, we have our sources matching, we have our sinks matching. What am I missing? I'm not sure here. and in Java. So the and here, no matter what language you're writing in, this is going to be like Python Boolean syntax. Um, so it doesn't matter. Um, Anyways, I'm going to keep continuing here since we have 3 minutes. So the way that we could then start to add our other conditions, let's say like, for the two features we have here that we want turned off. Um, let's say like param like entity is disabled, and we'll make that pattern one where yeah. So we're gonna say like pattern factory set feature, and then we're gonna use that focus meta variable. And I'm sorry, we need to group this all together so it all applies to one another. So we're gonna use our patterns block, and oh, how am I getting? Sorry, I'm getting myself mixed up here. So the label is fine here. We want to make sure that by side effect is true. And then we're going to have our patterns. And then our focus meta variable on, oh, that's why factory here. And so that by side effect is telling us when factory has this feature set on it, the by side effect is going to make this tainted. And that's important because then we can slap a label on it and say, hey, parameter entity is disabled. So by side effect is set to false by default, and that's why we need to set it explicitly. And so the reason why we'd want to do that is that we could then say, require user input and from factory, and not this case where the parameter entity was disabled. And so now we can have all of those conditions set, and so we now have a factory that, so all these conditions are flowing in, where this is coming, the document builder is coming from a factory, user input is flowing in, and that factory had a feature set on it. And so that's kind of how you can build stuff up with taint labels, with by side effect. And that really concludes everything that I have to show today. Thank you everyone so much for attending.